Hi everyone, my name is Kaushik and today I'm trying to solve the September late code challenge. The problem is binary tree pruning. So the problem is that basically given a root of the binary tree has been given and written the same tree where every subtree not containing a 1 has, if that a 0 has been present in the subtree, that will be removed. That is, a subtree of node is basically every node, every descending part of node. Basically I will be repeating one more times. Return the same tree where every subtree not containing a 1. So as an example of the first example there, so basically 101 and zeros left child has containing 0, so its subtree becoming empty because it doesn't have 1 value basically. So that is why I have been emptying the nullify that value, basically the left child. So that I required to do that. So what I will do that, first of all, first I will try and then after that I will try to make that code basically. So first I will run the first example 3 and then after that I will do the one more time another example with that. So basically hold on, I'll have to add the board basically. Hold on, just right board basically. Yeah, I added that. So right now I'll have to check my logic there. Basically 1 2 sorry, not 2, 1 1 0 1 1 0, and then after that 1 1 0 1 1 0 1 1 1 0 1, and the next part is the 0 basically, that is 0. So basically according to the question there, so I'll make it another color. So my logic is that basically first I will do that left child basically. If I'll go to the left child, what is that part will be 1 1 1, then 1 and then 0. So then after that I'll have to nullify that the if there is an one has not been present there. So I'll go to the next part. So after that, from there I'll go to there. So 1 and 0. So from there, so then after that will goes to there, and that is 0. So 0 will be, in that case its left child is null, and that is null, that will be required null. So in that case basically that I will traversing all of them basically, then it goes to the null value basically. So in that case I will return that null there. So and I'll check that is will also return that null, that is will also becoming the null, that is also becoming the null. So after that when it will be goes to there, so that time I will check that if my root value is 1 or left root left is not equals to null, or the root right not equals to null, in that case I will directly return root, and otherwise I will return the null. So basically what is happened, that will become the null. So after that part has been completed, so it will also return 1. So when that will be returned 1, so that part has been completed, is 1 1 1 and then 1, so that is become null, so there will be no record to do that. So after that I'll came here as 0. So that 0, if there is a left part is 0, so I'll go to there, that is goes to there, so it become null. So after that when it goes to the 1, that goes to, yes, it that goes to, that is also null, that giving me null. But after that that is a root, that is a root value is 1, so it will directly return root. So basically that's 1 has been fulfilling there. So not, then after that that become the null, basically that will not require to do that. So after clearing that, so my last of that, so 1 1 0, and then after that 1 and 1, and then after that 1. Maybe that is the answer. So let me check that. Yeah, that is the answer. So I am taking this example 2 there. 1 0 1 0 1 0 0 0 and 1. So basically what I'll do that, I'm making that the dry run through there. So first that goes to their left part, so that is 0, that goes to their, that goes to their 0, and then after that that become null. So after that it will become null, so it will return that, that is also null. So after that the left child of there, that is become null. After that, and after that will goes to 0, that is null. So after that, that is also return null. So after that the both of them has been return null. So after that, that's become the 1 and 0, so it will return null. It will return, both of them has been returning null, so it will place there. So after that 1, that goes to there, that goes to there. Then after that I will goes to left, that is the one part I have been reaching there, and 1 that goes to left, and that is goes to there, that goes to there. Both of them has been null, and after that it will return null. So after that it become empty. So after that so that is 1, and that goes to 1. So it will, the return value is the root value is basically 1, so it will directly return the root value. So there will be no checking that the, if there is an basically that the null value has been present or not. So basically the, when the root value has been present, in that case I will directly return the root value, I mean that root condition there. So basically that 1 0 1 0 1 basically, so it was also giving that left, and when that goes to there according to the recursive call at that point, that is a null, that is also null, it will return null. It will return null, but there is a root value is 1, so or directly it will return the 1, basically it will directly return the 1, and the, in that condition, that is why. So my output will be 1 1 then 1. So let me check that my answer is correct or not. Yeah, that is 1 1 1. So that's how I have been making there. So basic knowledge is that I have been pseudocode has been passing through the first I will check if my pointer is null or not. If null then return null. Otherwise the root left, that goes to there, and I have been recursively calling that, that's the function of root left, and otherwise that goes to there root right, that function root right. And after that I will check that, after that I will check that if my root value, the root condition there, is equals to 1, or the root left not equals to null, or the root right not equals to null. So in that case I will return the root, otherwise I will directly return the null value. So basic, that is the logic there. So I have been checking all of them now. So basically the order of n is the time complexity, and according to the recursive call, so basically the order of h is the stack space, basically there, the as the space complexity there. So Right now I'm trying to implement my logic there as a coding format. So if root is equals to null, then after that I will return the null. After that, the root left, not I am taking any variable because I have been checking that, because I will have to place that value basically. So that is why the prune tree, that is the root left. If that is returning null, then automatically it will be place the value as the root return null. The root right is equals to prune tree root right, and then after that I will check that if the root value is equals to 1 or root left not equals to null or root right not equals to null. In that case I will return root, otherwise I will return null. Let me check my logic is correct or not. Maybe my logic is correct. Yeah, it's giving me right answer. Let me check that one. Yeah, it's giving me both of them as correct. So right now I'm trying to submit them. Yeah, it's got accepted. Thank you so much.